goes on here. That's
Ooh.
one.
Oh, you do that so well.
Yes, well, this is the best part, you know, when you get rid of the whole thing. Let's turn it on, all right?
Right.
Okay, and you just pour this in nice and easy.
And this is going to emulsify the whole...
Right, and this thing will last quite a while. It won't separate because it's being held together.
I noticed you put the egg in first. Is that really
this
what
is
you
the way
have?
to do it, because that way you get a big concentration of the emulsifier, and it makes
Look
it,
at
you know, this thing is going to hang in there. It's the same principle as making a mayonnaise.
That's Art, you've done it again. You've come and helped me out with my cooking problems. I want to thank you very, very much for coming.
Well, thanks a lot, Ira, but can we eat now?
Okay, I'll flip you for the tab. We'll be right back.
Here's a man we can tell you now who's going to have trouble right from scratch. He forgot to fill his lighter and his match no catch. Things are certainly tough all over. Well, not all over. Now here's a couple of nicotine devotees who have gotten wind of a new wrinkle. These newfangled cigarettes strike and light right on the package. Where there's smoke, there must be fire. And where there's fire, yep, that's a smoke. The new style in self-lighting cigarettes was sparked in Italy. The striker is attached to the package. Even the fair sex have no trouble in obtaining a light. Well, not much. Strike up, sit back, and with this bright idea, you can sure save yourself a pack of trouble.
In spring, a young man's fancy turns to love in various forms, and his hot rod is one object of his affections. How better to bedeck his love than with electrically lit tires? We're not kidding. Some aesthetic Germans have come up with this idea to lend a little color to the drabbest feature of an automobile. Keep your white walls. Give me something in orchid and pink. I think 75 watts will do. Anyway, getting hit by this car is bound to be a shocking experience.
Technology marches on, I guess. Our next guest is Nancy Gibson of the Minnesota Zoo. Welcome, Nancy.
Thank you.
Now, usually you bring an interesting animal with you, but this time we sent you away on special assignment, right?
Yeah, and it was a great research mission. I went up to northern Minnesota to study black bears hibernating, and we actually pulled them out of a den.
You were brave enough to pull a bear out?
Right,
I want to see this.
Let's take a look.
Early this spring, I visited some wild black bears hibernating in their winter den. My guides to the woods of northern Minnesota were Dr. Lynn Rogers, a wildlife research biologist with the U.S. Forest Service. He's the one with the red hats, and his assistant, Steve Durst.
That sounds like it's really strong. I think we're getting it close.
Good.
Let me just listen once.
It's very strong.
Yeah, you're right on track.
Good.
The bear we were tracking was wearing a radio collar. Following its signal, we were hoping to be able to walk right to the den and find a mother and 1 to 3 cubs. For the last 18 years, Lynn has studied the bears in this forest. Radio telemetry has been a major tool in his research. Each collared bear had its own signal. By charting the bear's location throughout the year, he's been able to map out the area covered by each bear. Lynn has found that males travel great distances, but females stay within very defined areas. The female we were tracking has a territory of about 2,000 acres. We had to be quiet as we approached the den. Even a hibernating bear can wake up quickly.
I hope she's sleeping, but I doubt if she will be at this time of year. Okay, she's in there. You see her, Steve? She's looking at us. She's awake. And there's a cub.
And there's her shoulder right there.
Okay, let's stick it.
Using his records from past years, Lynn estimated that the bear will weigh about 175 pounds and prepared a hypodermic needle to sedate her. We waited several minutes for the drug to take effect. If she weren't completely sedated, she probably wouldn't attack us, but she might run and desert her cub.
Right.
All right, ready?
Uh-huh.
Oh, she's a
Here she
good-sized bear. How did she ever get in there?
She's a beautiful bear.
Wow.
Well, this bear we caught as a cub back in 1970. And it grew up with its mother. Finally, when this bear got to be 14 months old in the den with its mother, we came back to that den, put a collar on the cub, and a few months later, the cub left its mother, and we followed it every year since.
I know why they call you the bear man.
Lynn has found that most bears have their first cubs at 4 or 5 years old, but probably due to a lack of food, this bear was 8 before she had cubs, and since then, she has had offspring every 2 years. Now it's time to look for cubs, and I find myself deeper into this than expected.
This is a small entrance for me. This looks like a job for Nancy Gibson.
Oh, is that right? I can't get in there.
Sure you can.
Just keep going.
Just keep going.
I was surprised to find that I could crawl through the cave's narrow entrance. Inside was a roomy den with a nest of dried grasses. Finding the cub was a different matter. It had crawled out of sight and out of reach into a back crevice of the cave.
Come here. Come on. Yeah.
Way to go.
I got one.
Okay, just shove him back towards us. Okay, here, little boy.
There he is. Yeah, look at the world for the first time.
It's always exciting to see a bear, because every time I see one, it gives me one more chance to learn a little bit more about them. Let's put him over by his mother.
Oh, okay.
So you can say, hey, this is not too bad out here. Is it a boy or a girl? It's a girl.
This cub only weighed a half-pound when she was born in January, and she spent her first few months suckling on her hibernating mother. In her first year, the cub will learn her territory, what to eat, and how to protect herself. By next fall, when she crawls into a new den to hibernate with her mother, she will weigh 30 to 40 pounds. And by June of the next year, she will be on her own, and her mother will mate again. Next, it was time to gather the information so that we could quickly return the bears to their den.
Here, little cub.
What do we have there, a male or female?
It's a female.
Oh, great.
Which means that this is the bear that someday is going to take over the mother's territory.
Oh, is that right?
The
She'll
mother's-
leave the territory and then the...
They gradually shift over as their daughters grow up. And each
nice.
daughter gets a part of her territory, and eventually they take over her territory and she shifts over. This is such a nice, robust cub. You
Yeah.
hardly ever find them like this.
What do we have here for weights?
Let's see, what is it? 7 1/4 pounds, which is unusually large.
What's the average weight?
4 1/2 pounds or so.
Oh, so
So
it's
7
way-
1/4 is way ahead of the game.
Right.
That's
what-
because the mother is heavy. She can give a lot of milk.
So that means
Like all bears, this little cub is highly adapted to a specialized diet. In the spring, when she first comes out of her den, she will eat the young, tender grasses. By summer, they contain too much cellulose for bears to digest. So she and her mother will concentrate on other wild, delectable treats as they come into season. Berries, fruits, and nuts, especially hazelnuts, which are high in fat and protein content. And then a few ants and honey to spice things up.
To get through the periods when the nuts and berries aren't available, they've evolved this blocky body that's capable of carrying large amounts of fat and that's capable of minimizing heat loss in the winter. Instead of being long and skinny, they're short and fat.
yeah. Oh my gosh, 175 pounds.
That's what I estimated her at.
Is that right?
While the bear was asleep, we had a chance to look at a few other features.
Bears have dexterous toes for climbing branches and wrapping around branches.
Don't they also eat insects?
They eat insects. These claws are
Grubs
good
and
for opening logs. Their big teeth also are good for taking a bite out of a log.
Mm-hmm.
But their teeth, I mean, they grab holes out of logs, then spit out the wood, and then go after the insects with their tongue and lips.
An important part of Lynn's research has been gathering blood samples for scientists and medical doctors who have found that bear hibernation has implications for human medicine, especially kidney malfunctions and eating disorders. Unlike smaller hibernators, bears do not eat, defecate, or urinate all winter. If scientists can understand how bears are able to reprocess waste, it may help doctors treat their human patients.
In trying to find out what the mortality rates were from the bears and what changes occurred in bears' bodies between summer and winter, that led us to taking these blood samples, which when the doctors got a hold of it, they found really exciting things with good implications for human medicine. But the mother's starting to wake up, as you can see, and so why don't we try to get her back in?
This robust little cub with her healthy mother has a very good chance of survival. Depending on the weather, it will be only a matter of days or weeks before she and her mother emerge from the den and start foraging for food. A wonderful summer awaits her before her next winter sleep.
Well, I think we have a little bear cub that wants to go back and see her mother.
I think so, too.
Right. Lynn, this has been great, and thank you, Steve. It was a wonderful afternoon. Ira, I'm sure sorry you missed this. This little cub certainly would have kept you warm. But right now, she's going to go back and see Mom.
If you wonder about nature, you marvel at technology or the human body, or if you're just curious about the world around you, that's what we're here for, to answer your questions. So why don't we get right to our first question? And today it comes from
Jack Zilla.
Jack. You wrote us and had a very interesting question. Please share it.
I was wondering how our muscles work, say when you lift something.
It's sort of something we take for granted all the time, isn't it?
It is.
Yeah, good question. And here to answer that question is Dr. Jan Syria, our resident biologist from McAllister College in St. Paul. Jan, how do our muscles work?
Well, Ira, here's a real good example of how muscles work.
Listen, I have muscles and they don't work like that.
well, they could work like that if you worked out and increased their size. That would make them stronger and you'd be able to do that.
Well, what's going on there? I mean, what's going on with muscles?
Well, we're going to talk today about the physiology and the physics of how muscles work. I'm going to start with the physiology. I brought a muscle with me here.
Not a real muscle.
Not a real muscle, but a model of one. You know, the first thing that you notice here is that muscles always cross joints in order to work.
Oh, really?
If you had a muscle that was attached here and here on this one bone and it contracted, you'd just break your bone.
Not very useful.
No, not useful at all. Okay, if a muscle crosses a joint like this one does, then when it contracts, and that's all muscles can do, is just get shorter and contract, it brings this bottom bone up closer. And that's how we move our skeletal system. Our muscles keep contracting.
Well, if the muscle can only contract, then how do you get the bone back down again?
Right, because this can't push.
No.
Okay, you need another muscle. And that muscle comes around the back of the joint and attaches down here. And when it contracts, it pulls it back down.
Ah, well, very ingenious. Let me ask you this question. On our model, our muscle here has lots of little stripes and looks like strips of muscles, fibers they look like. Is that really how muscles are made?
Yeah, muscles are composed of bundles, actually, of long cells. And if you look inside these bundles and inside the cells, you find very long filaments, and those are actually going to contract. They get shorter. What happens is the filaments that are inside this fiber will roll past one another, like a boat on a lake, sort of. Okay, they slide past one another, and they are arranged in sequence or in series. And when they all do it together, then the muscle contracts.
Well, then let me ask you this question. What is it that causes us to become stronger when we exercise? What's going on with those filaments?
You just get more of those contracting units. So you have more of them, you can lift more weight.
And so therefore, am I using all my contracting units at the same time, no matter what I'm lifting?
No, you're not. If you would go ahead and lift this feather, I'll talk a little bit about what happens. It's really light.
Yes.
Okay. You're using this muscle in order to lift it, and you are only using a few of the muscle fibers that you have available to you in this muscle.
All right.
The ones that you're using, though, you're using completely. They're completely contracted.
So it's an all or nothing deal. It's a one-shot deal.
Right. Now, if you pick up the barbell, okay, now you're using more of your muscle fibers. And if you were trying to lift something that was just so heavy that you could just barely lift it, you'd be using 100% of the fibers you have available.
So then in exercising, I'm trying to use more of those little fibers inside my muscle?
Well, you get more of the contracting units for every fiber. So you just have more to work with.
All right, well, that explains the physiology. What about the physics that you mentioned?
Okay, well, we are actually a series of levers, and that's how we move. And I have brought a lever here.
Oh, you've got our Newton's apple seesaw, I see.
Right.